All right, so number 6 and 11.5 is a bit of a tricky one. So what I'm going to do is I'm going to walk you through this one. You will probably have to watch the video on this a few times when you get to your number 6. Here we go. So we got this minimum lottery problem. They talk about the minimum prize there, so I'm just going to call it that. The first thing they tell you is something about the cash prize. We don't care for solving this problem what the top cash prize is or what the minimum cash prize is. So those numbers you can throw away. Doesn't matter. All right. The way the game is played is players pick 4 different numbers, 1 to 51, and 1 number 1 to 41. Okay, so now I'm going to jump down to here. Player wins a minimum, again, I don't care about the value, if they match 2 numbers drawn from the white balls, whether 51, and the number on the gold ball, so there's only one way to do that, from the numbers 1 to 41. The question is, what is the probability of winning the minimum award? Basically, what's the minimum prize? How could we get the minimum prize? So the first thing I got to do is we got to find the number in the sample space. This is the number in the bottom. This is the denominator of the probability. Okay, so that's the first thing. So that's this game where we pick 4 numbers, 1 through 51, and 1 number, 1 through 41. So this is easy. We did it in number 5. I'm going to use my blanks. I'm going to label it. This will be the white ball, and this will be the gold ball. For the white balls, in my problem, it's the numbers 1 through 51. Okay, so I need to pick, the total possibilities is 4 of those balls. So we need to choose 4 from 51 total. Of course, the order doesn't matter. I chose 1, 2, 3, 4. That's the same as 2, 3, 4, 1. So 51, choose 4. And we got to deal with the gold ball. Okay. I'm going to just draw a light line here to separate the 2 things. And then for my gold ball, I have 41 balls, and I need to choose only 1. Okay, so the gold ball, we got 41 total. Let me say it this way: choose 1 from 41 total, and that's how I get 41. Choose 1. So I need to figure out this number. I guess I can probably fit it right here. I'm going to put the 2 numbers that I find here and here, and then I'll put my final answer down there. So 51, choose 4. 51, 51, choose 4. Big number, 249, 900. 249, 900. I'm going to draw an arrow so I knew that this was. Okay, now I got to do 41, choose 1. Obviously, that's going to be 41, but I can show you. Once you do enough of these, you're going to recognize the pattern. So 41, choose 1. It's just 41. Pretty obvious. That is that. All right, so that's where those two numbers come from. I multiply those together. Big number, 102, 45900. So this will be the bottom of my denominator. So I'm going to just kind of circle it so I don't forget that it's there. For the top number, step 2. Now we find the numerator. The probability, which is the minimum, which is the number of ways to find the minimum prize, or get the minimum prize. So that's what we got to do next. So this one's where the challenge occurs. Again, it's another just blank problem with combinations. Okay, so I'm going to read this again real quick. The minimum occurs when two numbers, notice, this is two numbers, are drawn from the white balls. Okay, this number will change in your homework. I've seen this as 1 and also as 3, but in this case, this number 2 is the number of ways we could choose the white balls. So I'm going to do my blanks right here. I actually need 3 blanks, and I'll show you what I mean. And put my little division line. Well, I said division line, I mean separation line. A little separation line here because this is separating the white balls and the gold balls. So the first thing here is I got to figure out the number of ways to choose the 2 white balls that are winners. Okay, I'm going to put winning white balls. So the way I can win in this example is I have, for this one, they want 2 white balls from the 4. Okay, so in this case, 2 white balls are winners from the 4 winning white balls, from the 4. So I only got to match 2 white balls from the 4. So that's why this part is 4 choose 2. I put another light separation bar there. Now I have to deal with the losing white balls. So the losing white balls, I also have to choose them, okay? So I have to do the following. Okay, this is a little tricky. How many total white balls did we have? We had a total of 51 white balls, 51 total white balls. And then we are throwing away the 4 winning white balls. So minus 4 winning white balls. So I am left with 47 losing white balls. That number, you're going to have to subtract off from the total they give you. That's the number that goes right there. 47, choose 2. Okay. In this case, the game tells me I only needed 2 to win, so I put 2 here. in your example, it may say you need 3 to win, then you'll put 1 here. So that's how these two numbers are there. They're not always going to be the same. They're not always going to be 2. And then the 1 gold ball that's going to be a winner, a gold ball winner. Obviously, that makes sense. There's only one way to win with this gold ball. All right, so I think I can fit this calculation down here. I'm going to do 4 choose 2 first. That's 6. 4 choose 2. Okay, so 6. Again, I don't know. I'm going to draw arrows to let you know where these numbers are coming from. So that number is right there. And then 47 choose 2. 1081. Of course, times 1. 6486. I'm circling this number 2 because this is the top number. I did all that work just to tell you that's the top number. All right, so I don't know if I can fit this all on this page, but I am going to try. Okay, so the probability of minimum prize is as follows: 6, 4, 8, 6 over big number 102, 4, 5, 900. Okay, I typed this in the calculator. Let me show you what happens. 6486 divided by 102, 45900. Of course, it's a decimal. And then I say, well, let's use our trick. Second PRB, still a decimal. That is probably where a lot of students are going to get frustrated. So I'm going to show you the only way to simplify this is just brute force piece by piece, okay? Notice, both of these are even. Both top and bottom are even. So divide each by 2. Okay, I got to do this by hand. There's no simpler way to do it. Trust me, I've tried. Even look for some patterns in the problem, but it's not going to be consistent. So 6486 divided by 2, 3243. 3243. And then this big number, 102,45900. Divide him by 2, 512,2950. Now, this is no longer even. This one is. However, and I know I go straight to this because I've worked it already, but if I know it's not divisible by 2, so I'm done with that, I'm going to go to the next prime number up, 3. Is this divisible by 3? There is an interesting fact about numbers divisible by 3. All of their digits add to a number divisible by 3. So let's see if the top is divisible by 3. I'm going to just make a note here. Let's see if these numbers are divisible by 3. Okay. So what I would do is I would start with the small number 2, then move up to 3, maybe up to 5. I don't think you're going to have to go beyond that. But anyway, 3 plus 2 plus 4 plus 3 is 12. 12 is divisible by 3. The top is divisible by 3. Let's see if the bottom is. 5 plus 1 plus 2 plus 2 plus 9 plus 5. That's 24. 24 is divisible by 3. Okay, so that means I can divide the top by 3 and the bottom by 3. Now go back to the original number. 3243 divided by 3. 1081. You'll recognize the 1081 over here. I tried to see if all the problems are divisible by that number, and not all of them are. So you still got to do this by hand. Okay, now let's do this number divided by 3. 5122950 divided by 3. Okay, 107. 1707. 650. That's about as far as we can go. Actually, that is as far as we can go. You could keep testing numbers, but that's it. Okay, so that's the number you get in this problem. And it's ugly and it's difficult, but that is how you do it. If you are working this problem in the homework or a quiz, you could pull up this video. You can see how I worked through it. I tried to talk through all the differences in your problem and this problem. But there you go.